Alright friends, we're going old school. For some reason the iPad is not allowing me to upload the document I need in order to do Unit 3, Skill 3. So here we go, pen and paper. Your essential question says, how can we identify composite transformations? So composite transformations is defined as two or more transformations applied to a pre-image. And remember that pre-image is what you start with. So example 1 says, in the diagram below, congruent figures, so we already know that they should be the same size as one another. 1, 2, and 3 are drawn. Which sequence of transformations maps figure 1 onto 2 and then 2 onto 3? So I have to ask myself what's happening here. I'm taking point D to make it D prime, and I'm moving over and up. I'm taking point A, moving it over and up. I'm taking point B, over and up. So every time we are sliding, so remember that a slide means a translation. So I'm going to cross off choice 1 and 2. And then I have to decide how do I move figure 2 onto figure 3. So it looks like it needed to turn itself. We do turn counterclockwise, even though you could think, oh, it's got to turn this way. That's okay, as long as you recognize it's a turn. And so here we're choosing rotation after the translation. So explain why the three figures are congruent to one another. So in this, translations and rotations preserve two things. Remember, distance or length, however you want to say that, and angle measure. In example 2, we're asked to define a sequence of transformations, so again, 2 or more, that would map ABC onto the double prime. So we're starting here and we're moving here. So there's a couple options. You could do this in a couple different ways. The first thing I noticed, though, is that they're not at the same height, right? So I might want to consider moving this up. So if I were to move it up and up and up, it looks like it would land here. So the first step I'm going to take is to translate up 3. I'm not translating left or right at all. I'm just going to translate up. I could translate left and right if I wanted to, but I'm going to choose not to. The next thing I'm going to do is figure out how to get like this side to come over here to this side. So it looks like it needs to flip. And remember that a flip is called a reflection. So step 2 will be a reflection, but I have to define over what? Reflect, messy handwriting, over something. If I try to reflect over the x-axis or the y-axis here, it's not going to put it on top of what I need. I could then take a third step to translate again, but instead I'm just going to find the line that's exactly in the middle of A double prime and what would be A prime. So it looks like they are 1, 2, 3, 4, 5 boxes apart, so halfway through would be 2.5 boxes. 1, 2.5. So I want to reflect over this line. At this spot, I'm crossing over the x-axis at negative 1.5. So I'm going to reflect over x equals negative 1.5. Another option would have been to move this up and bring it all the way over and then reflect over this line. Another option could be to immediately reflect and then translate, and you could have immediately reflected over the y-axis here. So again, there's multiple options. Next it says, which sequence of transformations maps triangle ABC onto DEF? So ABC is first, DEF is where we will end. It might not be done in one step. Actually, it won't be because it says sequence. So you're just going to read through each option and decide what works best. If we were to reflect over the x-axis, that would take A up here, and sometimes it's helpful to sketch out where it would go. And then C would go up here. Ooh, I'm liking it so far. Because then A has to definitely map onto D, and I know that for sure by stacking these letters. So A could flip over then the y-axis, C could flip over the y-axis, and so could B flip over the y-axis. So if I were to reflect over X and then reflect over Y, that could get me where I need to be. If I instead did a 180-degree rotation around the origin, it would actually land me there in one step. And because it has to be a sequence, I know that it has to be 2 or more. So I'm going to choose number 1. You could work your way through the other ones to see why they're not it, but I'm going to just stick with number 1. Describe a single transformation that would reflect triangle ABC onto DEF. So as we just said, a 180-degree rotation about the origin or centered at the origin. And if you were to write this in notation form, symbols would be capital R. You write the origin, and then comma 180 degrees. Another option, which we very rarely talk about, is to reflect through the origin. These two things are the same as one another. Reflect through the origin would just look like lowercase r for reflect and then the word origin. Usually we reflect over a line, but you are allowed to reflect over a point, and essentially it just rotates at 180. I think this is our last question. Nope, 2 more. So it says AC is congruent to DF. And it says they are collinear on a line. These points are on the same line is what they're saying. Collinear means on the same line. Let D prime, E prime, F prime be the image of DEF after a translation along L such that point D is mapped to point A. So they're saying D comes and translates towards A. So if this is now D prime, that means F should slide here to be F prime, and E will slide here to be E prime. So it's just like translating on a graph, except we didn't have a graph. Okay, so it translated along the line L. That's an L, by the way. Says determine and state the location of F prime. So, well, it's located at C, and it says explain your answer. This is the part that's a little weird and a little tricky. You do have to be super specific here. And this is because translations, you know this first part by heart, translations preserve distance and angle measure. And since, this is the new part here, since AC is congruent to DF, if A maps to D, then F must map to C. So the word map here just means that it moves on top of, it goes to. Last part here says the double primes is the image of the primes after a reflection over line L. Suppose E double prime is located at B. So they're saying E reflects over the line L to become here, E double prime. Is triangle DEF congruent to triangle ABC? So are the two triangles, the original and this one, going to be congruent to one another? The answer to this, of course, is yes, because, and we're going to refer back to first the translations, and reflections. Preserve length. If you prefer the word distance, use the word distance. And angle measure. One more question. Triangle MNP is the image of JKL after a 120-degree counterclockwise rotation about Q. So this little section is just showing that they took J, they rotated 120 around point Q, just as if that was the center of our rotation on a grid. So it says the measure of angle L is 47 degrees. And N is 57 degrees. Determine the measure of angle M. So I'm going to choose to call that X. Explain how you arrived at your answer. So first off, whenever you see letters up here like this, you should get in the habit of stacking them. That's going to help us in Unit 4. So you might as well get in the habit now. This is telling me that M maps with J. So whatever M is, J is. So I could choose to put the X here too. N maps to K. So whatever N is, K is. And then P must go to L. So if L is 47, then P is 47. So holy moly, these triangles must be congruent, right? Because a rotation preserves length and angle measure. So that'll be how we explain our answer, but we do have to find this X. So we know that X, 57, and 47 in a triangle should make 180. You don't have to set up this equation. You could solve it by doing 180, take away, right? So here I have X plus 104 equals 180. And then I'm subtracting 104, so X equals 76. So then I say the measure of angle, M equals 76, because there's two reasons here. Rotations preserve length or distance and angle measure. That's the first. Sorry again for the messy writing. I'm just trying to go quickly. And we know angles in a triangle equal 180. All right, that's it. 3.3 is just combining two or more transformations to make a composition.